So we've got a couple more talks in this session. We're going to kick off with Samhita. Make sure we do another big warm welcome. I know everybody's just come out, shake their, tail feathers. I don't know where that was going. But settle back in and get ready. We're going to kick off. And up we come. Big round of applause, please.
Hi everyone, can you hear me okay? Yeah, okay. So I'm Samhita. I work as a principal data engineering tech lead at HP. And I started my career as a software engineer and then accidentally transitioned into data engineering. And I'm loving it ever since. And so here I am working around data world for about, I think, 8 years now. And when I'm not working, when I'm not fixing the broken data pipelines, I like to spend time helping others navigate their careers in data and also transition their careers into data. So that's a brief intro about me. Now let's look at the stat. Did you know that Gartner predicted by 2026, 60% of the AI projects are going to get abandoned? Gartner predicted it a few years ago, but here we are already in 2026, and we are seeing it happen in real time. And one of the main reasons for this high failure rate has nothing to do with AI itself. It is the data that we are feeding to the AI. Which brings us to the topic that we are going to talk about today, which is how do we make our data AI ready or agent ready? So let's have a look at the agenda, what we are going to talk about today. I will start with the AI evolution and the factors that has led to this AI rush, specifically now at this time. And then laying down the data foundation, talking about the risks, the possible risks and the possible ways to handle the risks, and finally, what the future looks like for us. Okay, so let's start with the AI evolution. So we have come a long way in AI. And the first AI machine takes us back to the time of World War II when Alan Turing, along with his team, has built an intelligent machine to crack the secret German military code. And I'm sure a famous movie, The Imitation Game, was also made on this story. And I'm sure most of us have watched this movie. And then fast forward to 2000s. We have been using machine learning algorithms almost everywhere. We have been using machine learning algorithms to predict the inventory demand and to predict the fraudulent credit card transactions. And fast forward to now, suddenly everything has changed. We have been using this Gen AI tools like ChatGPT, Gemini to write our documentation, write emails, create presentations, and sometimes using ChatGPT for market research as well. And sometimes I use ChatGPT for shopping as well. So it feels like suddenly like we have transitioned from a slow, steady walk to an absolute sprint in the blink of an eye. Which brings us to the million-dollar question, why this sudden rush in AI and why now? To understand that, we have to focus on three things. So let me first start with the brain. So if I say a statement that calories in an apple, so it immediately reminds me that, okay, apple is a fruit, it is a healthy fruit and apple has some calories. Now imagine if I add another extra word, calories in an Apple laptop. Suddenly it does not make any sense because I know Apple is a laptop and does not make sense for a laptop to have calories, right? I understand that because humans understand context. But for a very, very, very long time, AI did not understand context. It was not able to differentiate between calories in an apple versus Apple laptop until 2017. In 2017, Google published a paper called Attention is All You Need, where it introduced the concept of self-attention through transformer models. And finally, AI was able to understand context. So, but these transformer models had some problems. These required huge amount of computational power. Which brings us to our second point, which is the muscle that has led to this AI rush. So it turned out that the same GPUs that NVIDIA was making for rendering high-end gaming graphics and crypto mining could be used by the AI to run this high computation. So this actually changed the game in three huge ways. So suddenly, training a huge amount of data set, massive data sets, became affordable, at least for the big tech players. And AI now could be packaged as SaaS, meaning everyday business could just buy access to it. And the third point is, data processing got so fast that we were able to process data at near real time. Okay, so we talked about the 2 points, that is the brain, the muscle, which has led to this AI rush. Now let's talk about the third point, which is the access. So OpenAI put ChatGPT out there for free, and suddenly everyone could access AI, which was not the case before. AI models were strictly for corporate use, and developers now could just plug into these models through APIs at a fraction of cost. And everyone was talking about it, and billions of dollars poured into the AI startups. Um, and because no one wanted to be left behind in the race. So here we are, we have these amazing tools, which is great. But I want to ask a serious question. Can these tools, as they are now, can these be used at enterprise level work? Not really, because these tools, these GenAI tools, are fundamentally reactive, meaning these are just sitting there waiting for your prompt. And what happens if it gives a bad answer? You have to write your question again, like you have to redefine your prompt. So you have to micromanage these tools again and again. But to be truly efficient at enterprise level, we want something that can consult itself, make some decision, and take actions autonomously. Yes, of course, it can reach out to human, but when it is necessary, when it is absolutely necessary. So this transition from this reactive chatbot to autonomous worker is what we call as agentic AI, and this is what we are going to talk about today. Okay, let's see this hypothetical agentic chatbot. So the user persona for this agent is basically the executives. So suppose we ask this question. So what was the sales last month? So what really happens when we ask these questions? What happens in the background? So as soon as we ask the question, the agent first analyzes the question and plans all the tasks that it has to execute. And first it will check the access control data of the user, that whether or not the user who is asking the question should or should not have access to the sales data. And then it checks its own access control data. And then it finds out the database and schema where the sales data is located. And then it writes the query, the executable query, and runs the query and waits for the query to finish. And when the query is finished, it will fetch the result and attaches this result in the chat. And while it is doing all these activities, it will also save this conversation in memory, so as to make sure that when something similar is asked in the future, it can save time in planning. So in the entire flow, the agent, what it has done, it has planned the task, executed the task, and also done some reasoning, because it was also checking the access control data of the users, so whether or not the user should or should not have access. And then it also remembers the conversation to save time in the future. Okay. So if everything becomes autonomous, the question is, can we just plug into these LLMs and start deriving insights automatically? Not really, because these LLMs are generalist and kind of trained on the publicly available data. This does not know about our company-specific data sets or documentation. It does not have the domain knowledge or stakeholder knowledge, right? But we still can get the benefit though from these LLMs if we are able to fine tune this LLM with our data. So how do we fine tune these LLMs with our data? We need before we do that, we need a place where we can store all of our data and collect this data and structure it as needed. To explain this further, let me draw an analogy here. Think of a busy restaurant which serves delicious meals, and they also have a very good customer base, pretty happy customer base. So what really happens in the background? How is the logistic managed? So I'm oversimplifying the process here. Let me just say that, okay, a food truck comes in and then loads all the ingredients in a loading dock, and then we would have to sort and label the ingredient and store the ingredients in their designated area For example, dry goods would be stored in pantry and frozen goods would be stored in freezer. And then we would also have to make sure that the temperature of certain ingredients is maintained so as to maintain food safety. And we have to do all this process very quickly to ensure that we are not wasting any food and also to ensure that customers are getting food on time. So now you may ask, what does it have to do with data? So in our modern data architecture, our situation is also very similar. We are receiving data from all sorts of sources like operation data, cloud data, social media data, and whatnot. So we also need a place where we can store this data very quickly, so as we can derive value from it at later point of time, which is where data lake comes in. So data lake allows us to store the data very quickly and also at a very cheap rate. But there is a problem. The problem is with data lake is that the data quality in data lake is not of good quality, just because of the way we are loading it. And because it is of not of good quality, the consumers cannot access it directly. Like going back to the kitchen example or restaurant example, we are not serving the meals directly from the loading dock, right? We need to process it, we need to clean the vegetables, chop it, and do some processing. So similarly here, we need to clean the data, filter the data, and transform the data from data lake and load it somewhere, which is called data warehouse. So the data quality in data warehouse is pretty good, but it also has a problem. Storing in data warehouse is pretty expensive. So just like the freezer, we can't store everything in freezer. So similarly, we can't store everything in data warehouse. So to address this problem, architects said that why not have the best of both worlds? So they combined the concept of lake from data lake and warehouse from the data warehouse, and they came up with data lake house. So which gives us the cost flexibility of the data lake and also the security and data quality from the data warehouse. So we have data lake house, and we will be able to give significant context to the LLM from the lake house. But lake house also has a limitation. Lakehouse will only contain information that has been fed to them very consciously. So it can answer well-defined structured questions like what was the sales last month, but if you ask something like why my supply chain broke down last week, or why the NPS score of a client is been declining, it will not be able to answer it just because it does not know. It does not know that there has been a surge in the support tickets in your ticketing system and also a few negative comments in the CRM tool. It does not have that information. But we as developers, we can say that, okay, we can get that information and we can get the data by writing some custom code or by consuming some API endpoints. Yes, we can do that, but this is just for one application. Now imagine that you have 20 to 30 such applications. So the cost of managing all this custom code becomes really high and it becomes really complex. So to solve this problem, Anthropic came up with MCP server, which is Model Context Protocol. I think we also have a session coming up sometime later with about MCP server, which it will be discussed in detail. So Anthropic came up with MCP server, which is like it will give you a machine readable map of all the available actions that the resource has, all the available actions that the tool has exposed, and also the guidance on how to use those resources safely. So this gives the opportunity to the LLM to explore all the resources that have been exposed. And because the LLM is also intelligent, it can take decisions on its own and it can take actions and choose which resources to use. So think of MCP as USB hub. So how back in the day we used to have this individual wires to connect various devices to the computer, like we used to have these wires to connect keyboard to the computer and mouse to the computer, but nowadays we don't do that. We use USB hub for that. So MCP server is just the USB hub for AI. Okay, so Lakehouse and MCP server can give significant context to the LLM. But now let's take a step further. Now think of a task where the LLM needs to review the financial report of your distributor. Yes, of course, it can raise some alert or it can send you notification if there is a fluctuation in revenue. But is it really useful? Operation wise, it is not very useful because you don't know what to do with this information, because we don't know what actions to take. And because simply we don't know the reason what has been happening, so we don't know what to do. Now, and why the LLM is not able to give that information to us? Because again, it does not have context. So, yeah. Yeah, so your human engineers and analysts still need to look through the work emails or weekly status report to find out the reason. And suddenly we realize that the most important chunk of information is not in the lakehouse or it is not in the MCP server, but it is lying around in some work emails. So how do we derive value from this fragmented distributed data set? But before we start thinking about deriving value from this fragmented data, we need to store the data somewhere, which is where vector database comes in. So vector database allows semantic search of your query, meaning that you don't have to search for the exact keyword, but it understands the context, and based on the context, it will be able to give you the most relevant passage from the database. So think of vector database as an intelligent librarian. So even if you don't know the exact name of the book, but you are able to, but you know the idea and the concept, and if you explain this idea and concept to the librarian, then they will be able to give you the most relevant passage from all the books in the library. And how do we get information from this from the vector database? For that, we use a mechanism called RAG. So we integrate RAG in the automated pipeline. So whenever there is a fluctuation in the revenue, so RAG will retrieve all the relevant information from the vector database, and then it will synthesize all the information and get a clear understanding of the situation. And then it generates the output with the reasoning that why there was a fluctuation in the revenue. Okay, so we talked about making our data agent ready, but let's be real about the risks. Let me first start with amplified vulnerability. Now imagine that if due to a simple integration error, if the sales has been declining for a product, what would an agent human analyst do in this case? They would just say, yeah, okay, wait, let me just check what just happened. But the agent might think that this is a real trend. And the agent, we have to remember that the agent is also taking actions autonomously. So it might slash the marketing budget of the product, and then it might move the marketing budget to somewhere else. And by the time the human analyst gets a chance to review the situation, the damage has already been done. So just because of the way these agents operate, when things go wrong at scale. Moving on to the second point, which is data governance. So this is what I call a self-inflicted wound. So this usually happens when we don't have good data governance strategy in place. So what do we have here? Hallucinations. So when the training data of the model is not of good quality or it is corrupted, then the agent might hallucinate. So for example, it might come up with new or fake company policy. And what happens when it shares this fake policy with the client? Our reputation gets a direct hit. Next, we have model drift. So this one is pretty sneaky. So at the beginning, the model might behave as it is, the agent might behave as it is expected to behave. But with time, as more and more data gets ingested in the model, it might drift from its behavior, meaning that it might change its behavior. And suddenly, we realize that it is taking actions that it was never authorized for. And then we have shadow agents. So the AI competition is getting pretty intense, and some teams are spinning up their own AI agents way faster than IT can ever review them. And because these agents are not reviewed by AI, then these agents have a huge risk to expose sensitive corporate data. And then we have copyright information. So without good process control, there is a huge risk that we are using someone else's copyrighted information, or the other way around, the way was thing, like there is also a risk that we are exposing our secret code to the public domain. So these risks are not always accidental. We also have risks coming in from security threats as well, which brings us to our third point, which is data-specific attacks. So what do we have here? Memory poisoning. So hackers are now trying to hack the long-term memory of the agent. So they are trying to feed bad data to the agent so as to make sure that the agent act maliciously over time. And then we have data exfiltration, where the hackers are trying to verbally manipulate the agents. So they are trying to trick the agent to share some secret keys like service tokens or admin credentials. And lastly, we have regulatory and ethical challenges. So if our training data of the model is biased, then the agent obviously will take biased decision. And just because of the scale at which they operate, it will not just make the biased decision once, but it will keep on making those biased decisions. So the question is, how do we build without risking things? We have to obsess over security and governance. So I like to break it down into two buckets. The first one being technical safeguard and process control. So what do we have in technical safeguard? It is interruptibility. So suppose your agent starts acting funny, and in the middle of the night it starts sending wrong attachment to the client. Then we need to have a kill switch to immediately pause the system instead of waiting for someone. And then we have human oversight, human in the loop. So yeah, of course, AI can do the heavy lifting like calculating customer refund, but then we again have to have human in the loop to approve that transaction. And then we have confidentiality. So for example, suppose the agent is summarizing customer support call, then we need to have a system or a filter which will mask or filter the customer PII data like credit card number or name even before the agent reads the transcript. And then we have access control. So we need to have a policy in writing what the agent should or should not access. For example, the customer support agent should not have access to the HR payroll database. And then we have continuous testing. Obviously, we have to run mock scenarios very frequently to check whether or not our models are hallucinating or whether or not it is drifting from its behavior. And the next category, we have process control, defining actions. So again, we need to have this policy in writing what the agent can or cannot do. For example, the agent should never be able to drop or delete a production database. And then we have auditability. So we don't like black boxes. So suppose, for example, if the agent has rejected a loan application, then we need to have the exact trail of the logs, exact trail of the data points that has led to this decision. And then we have monitoring. So of course, we need to have eyes in the system. So for example, we can have a dashboard which flags us immediately if the model is giving two different answers to a same question. And the last one, it is very important, accountability. So when things go wrong, who should take the blame? So we need to have that policy in writing as well. Okay, so where does all of this leave us? Let me talk about this question. I'm sure everyone has in their mind whether or not AI will take our jobs. I think AI definitely has the potential to do the repetitive stuff like ingesting from same data source or learning from a ticketing system to fix a familiar bug. But I think from data side of things, our roles are going to be evolved, and I think a lot of human skills are also going to be very critical. Take for example, architectural design. So AI fumbles really hard when it comes to designing big scalable platforms. We still need humans to do that big structural thinking. Another skill which I think is going to get very critical is debugging. Yes, of course, AI can help, but when the critical systems are down and the pressure is on, we still need humans to roll up their sleeves and do the debugging to find the root cause and fix the bug. Another skill which I think is going to get very critical is stakeholder management. So stakeholder management still is very critical in data engineering, and I think it will continue to remain important. We are also going to see a lot of new roles pop up. For example, platform management roles. So think of the people who will manage this platform where these agents live, and a supervisory role to keep AI actions in check and to make sure that guardrails are met. And domain expertise, it is still very critical, and I think it is still going to be critical in data engineering. So to summarize, in conclusion, AI, I don't think it is necessarily replacing us, but it will definitely redefine the way we work. Thank you so much for your time today.
Thank you very much. Do we have questions? Oh, okay, up the top. Everybody, entertain yourselves. I'll get there. No, it's fine. Hey, how is it up here? How's the view?
Thank you so much, Samhita. That was wonderful. And I have just one question there. Now the tools are being built with an agent AI already in it. Say like Jira has got Rovo. So how are we going to control the administration of such tools with an inbuilt AI agent, where it has got access to all of those that we do, on a regular basis on a Scrum or a Kanban board. We always have got Rover monitoring us. So how are we going to keep us safe?
So in my experience, what I have seen that when the agent knows the context, like knows the data that we are talking about, and I don't have to give new context to the agent, it really helps. And I feel safe because, like you said, Jira is integrated with agent, and we are using all kind of IDE like VS Code is integrated with Copilot, right? So I feel safe, and I feel that most of my time is being saved because I don't need to explain it from the scratch that what I'm going to do and what I'm expecting from it. So in my case, I just give it this example that okay, this is the ticket. So when I'm working with Copilot, this is the ticket, this is the context, and this is what I'm expecting from you. So just try to write the code, and then I keep on modifying it. Yeah.
Great. Lovely. Thank you very much again, Samhita. Thank you. I have to say the nervous giggle that went round the crowd when there was the question about is it going to take our jobs, that's a moment that will stay with me. Nobody wanted to do a big laugh, but we all felt it, didn't we?